button. All right, so which team will be the next?
I think ours.
All right, you're ready to go. And what's your team number?
3, undergrad 3.
Undergraduate. All right.
Do you guys see the screen?
Yes. Yes.
So for this project, we decided to only focus on the scale tower right here. And I'm going to talk about the first 5 classes, and then my partner Vladimir is going to talk about the next 5. So for the first one, we saw that this cable tray right here, it's intersecting the distribution box, and we decided that the best solution is to move the cable tray to pass right next to it so it doesn't intercede with it, because if we move the distribution box, it will be much difficult and we will have to move the whole system. The second clash we found was that this egress system, as you can see, this wall right here, it has like a trapezoid shape, and the egress system has a cutout, but it does not align with the trapezoid. So we suggest to make the cutout a little bit farther so it fits right through the trapezoid, because changing the structural will be super hard and costly. And then the third one we found was here that the duct system passes lightly through the hole, but not completely. Some part of it passes in the actual wall, not the hole. So the best solution is to move the hole a little bit to the left to then make sure that the whole duct system falls through the hole.
Just a quick question here. Why
Yeah.
wouldn't you move? Why wouldn't you move the duct but the hole?
Because then you have to move the whole duct system, and that will be costly for the engineers and the owner of the project.
Okay.
For the fourth clash, we found this, not that one, this one. It was the dust collector right here, seen in green. Sorry. It's slightly intersecting with the maintenance system in red. So this one will be hard to fix because both systems depend on other things. But we think that if we can make this piece right here turn closer to this side than this side, it will be better for it. And we can just fix it like that. And then the fifth one was the most intriguing one, which as you can see here, the dust collector system, the red, let me see if I can get the view and I'll show the picture. Yeah, I'll just show the picture. Do you guys see it, the picture?
Yes.
So you can see here both the duct system and the piping going through the duct system are not aligned correctly, like the shape are not aligned perfectly. So we will have to move the green one slightly to rotate it a little bit so it fits perfectly. But the problem with that, it will be that it will intersect with the rest of the system. So we will have to move both things and make sure that they align perfectly. And now Vladimir will talk about the next 5.
Okay, so can you guys see my screen?
Not yet.
Not yet. Loading. Still loading.
Okay, I think I'm back. Okay, now?
Yes.
Okay, got it. So the sixth clash that we find on the building, on the scale tower, is actually a clash with the electrical dots, the electrical tray, sorry. And as you can see, the electrical tray is actually like passing through the external wall of the building. Let me see if I can show you better. So in these corners, the electrical tray is passing through the external wall. So a solution for this, the solution that might be beneficial for this clash is to changing the size of the electrical dot so it can fit perfectly the hole in the wall, or increasing the size of the hole in the wall are going to be like two of the solutions that we have to solve in this clash. The another clash that we find is the same problem. It's not the same problem. It's like the same structure, and also the electrical dot. As you okay, maybe have some difficulties with the program. It kicked me out of the model. I'm just opening again. I'm so sorry.
It's fine. It happens all the time.
Okay, I wasn't here. Is my screen good?
Yes.
Okay, as I was saying, the problem in this clash is that this embed plate is actually like passing through the tray, the electrical tray. For a solution for this clash is just to decrease the size of the electrical tray, and if that's not possible, you just have to like move a little bit to the right the electrical tray, just that it doesn't like intersect with the embed plate. So this is a clash between the mechanical system and an embed plate that I think it doesn't supposed to be there, because I didn't see like any purpose of having like a embed plate in the mechanical system. And I think this is just like an error in like the design of the structure, because as you can see, there is like a inlet plate already right next to that one, and I just think that while the engineer was doing like the design of the structure, they just misplaced that inlet plate over there, and then you just have to be like remove it to solve the clash. Here was like I think one of the like most dangerous clash that I found it like in the structure, because this red column over here is like a structural column, and it's actually like crashing with a mechanical equipment, a maintenance equipment inside the tower. I don't know if you can see that. Sorry, right here. You can see like the green is the maintenance equipment, and it's actually like passing through a structural column. So that's like very dangerous because can give like instability to the structural column. So for this clash over here, it's just like that simple to move this maintenance equipment to the right a little bit, so it doesn't like crash or pass through the structural column that is the one that gives you like all the support to the building. And so just 1 second. So right here is our last clash. It's just like a dot that is like part of the sampling conduct that goes through to this building over here. This dot is actually just like passing through the wall, the external wall, and there's no like a hole in the external wall. So I think this is like a problem, just that since there are like different people like working on the structural design, and also are people like working in the mechanical design of the project. So in this part, there was just like a human error, and they didn't communicate well to put a hole in the external wall so that the round dot can go through the wall. So a simple solution for this is just like open a hole in the wall so that the round dot can pass through the wall and doesn't like crash with the wall, like doesn't pass and goes through the wall. And yeah, that's all our 10 clashes that we find in the scale tower. I don't know, guys, if you have like any question.
Thank you. So no question, but maybe a quick comment. So I noticed that from what we have today, a lot of clashes are between different disciplines. So the reason is a lot of designers, they work in silos. It's very difficult for them to have one disciplines of design, such as structure, totally completed before moving to the next discipline, right?
Yeah, correct.
So I guess ultimate cure for that is cloud BIM. Like it's kind of like a Google Doc. Like if everybody can log into the same model at the same time and see the changes in real time, that probably would help them have a better sense of the spatial conflicts and reduce the number of clashes. So not a question, but maybe a quick comment.
Yeah, and so they can use the BIM cloud to work together in like the same project.
Mm-hmm.
That is like an excellent tool that, well, AutoCAD have.
Yep. All right, thank you guys. So this is let me check. This is undergrad team 3.
Yeah.
All right. Yeah.
So which team is the next?
I can go next.
All right, sounds good.
I believe I'm undergrad team 2.
Undergrad team 2. All right.
Okay. All right. So here is my clash detection report from the provided Navisworks model. The tests were run with a tolerance of 0.001 meters. And so, all right. All right, and as an introduction, structural classes, after I ran the tests, I exported them into Excel to try to find out which elements were clashing the most and kind of prioritize those for the 10 most critical. So I was just looking to see what was clashing and how often it was clashing. And as it says here, structural clashes I thought were more significant, as well as clashes that seemed to impair safety or operation of the facility once it was complete. So for the first clash, it was this duct here, passes through this red area, which is a maintenance area for workers to go in. And I just noticed that the duct went through it in a way that could prevent people from getting in there and doing what they need to. So I would suggest either moving the duct in a way that the HVAC plan allows, or relocating the maintenance area in a way that is still possible to access that. And these are not in any significant order of importance. It's just kind of in the order that I noticed them. So in this clash here, you can see the conveyor belt, which is here on the Navisworks model, is clashing with the wall that it's supposed to go through. And you can see under here that there are cutouts that it's supposed to go through that the model does not seem to follow. So my suggestion would either be to adjust that and add holes where the conveyor belt is going through, or lower the conveyor belt if possible and design allows it to. And this clash here was from the rail system that encircles the facility. And I noticed, I believe it was about 265 times that this appeared in the clash test, that the ties for the railway were either intersecting with the local topography or with structures near the railway. So I used this as an example to say that this needs to be adjusted either landscaping wise to clear the topography around the railway more, or to just ensure that structures don't interfere with that. Okay, and then this column that goes through the building clashed with several components. I chose this floor here as the most important. And this floor just needs to be reshaped in a way that allows the column to pass through it. And then this here is another maintenance area labeled in green, which has a steel beam passing through it in a way that would block workers. So if possible, I would suggest moving the steel beam as long as it doesn't damage the structural integrity of the building. Then I do believe that this beam should be relocated. And if not, then adjustments would need to be made to the maintenance area to allow access. The sixth clash was with a designated electrical working space area and a maintenance area for mechanical equipment, which in the model completely overlap. And I thought this looked strange enough that it was worth mentioning that I don't know if this is intentional and if maintenance areas are supposed to overlap for different disciplines, but it seems strange in the model. And I would suggest moving these to different locations. And then here is another on the conveyor belt moving up, that there's a steel beam passing directly through all of this equipment that is necessary for the operation of the conveyor belt. So this beam needs to be relocated so that it is not doing that, because that's impossible to build and the equipment needs to function in order for this facility to run properly. And this green area here is another maintenance area that has a duct passing through it. And in the model, this is marked as a separate clash, that there's a valve and operations for this. But this vent just enters it in a way that blocks the path here, and I believe causes an important safety hazard that should be remedied by either pushing the vent back so that it doesn't protrude as much, or allowing the maintenance area more room. This is another duct that intersects with another maintenance area, the duct here being in green and the maintenance area in red. The duct passes through at an angle that would completely block anyone from going through without ducking or crouching to get underneath. And I believe that this needs to be relocated either by moving it above or below the maintenance area. And then this, it's kind of hard to see in this picture, but this green pipe here sticks up through the floor in a way that could cause a trip hazard or just general safety areas, especially so close to an open railing. And I believe that that should be cut slightly to be underneath the floor so that it doesn't create any hazards. And that is all 10. Thank you.
Thank you, and I really appreciate you discovered some safety hazard. Usually we focus a lot on the hot, clashes, but definitely enough clearance and potential safety hazards are also targets of clash detection. All right, so just to clarify, Andrew, so for this clash detection, you are on your own, but you are moving to one of the teams, right?
Yes, that's correct. I'm going to move to, I believe it was team 5.
Okay.
But yes.
Okay, that sounds good. Yeah, I will mark it up.
All right.
All right, so that leaves us the last team, which is which team?
That would be me. However, I am seeming to having some technical difficulties. I can't pull up anything on my computer.
And Eric is not here today, right?
No, he is not. So do you just want to push it to next week?
Yeah, that's definitely work for me.
I apologize. I already submitted it in the thing, so it's there, but I waited till the end, and then my computer is now not being my friend.
Not a problem. Yeah. Okay, so yeah, guys, let's finish this evaluation for undergraduate team 2, and let's take a 5-minute short bell break, and let's come back at 6:02. All right. Sorry, 5:57. All right. See you guys then.
There I am.